Hey everyone, I thought I'd just make a quick video addressing the issue that I found with our collision handling system and how I fixed it. So I'll preface this by saying I'm not entirely happy with this solution, and it is not. I will continue working on my own at a better solution, just because I don't know. I'm not totally satisfied with it. I think there is definitely a way to make our previous system work, but I sort of had to change our methodology of how we actually resolve collisions. So let's take a look at the problem, at like what was actually happening. Luckily, it was nothing with our the problem was nothing to do with our like quad tree system, like our whole idea of recursively subdividing the 2D space. All of that works totally fine. The problem was purely within our resolve collision method and the intersects method. So what was happening is if two objects were moving at each other, so moving in opposite directions, like this, they would just pass right through each other. And if they were moving, any other direction, it was totally fine. It worked just as normal. But in this case, what was happening is one of these is going to get resolved first. And so say the red one gets resolved first. So the red one, if it was going to move, like in here, it will instead get, which is a collision. So this is clearly an intersection. So the red one knows about this intersection, and then that gets resolved. And the red one's velocity gets updated so that it only moves to this point, right? But now at this point, the black one needs to get resolved. And the black one is moving, but now that the red one has been like fixed, its velocity has been fixed, the black one will no longer think that it's going to intersect with the red one. I think that was the problem. That's the main problem. There were a couple like minor things in the way that I was checking intersections that were also a bit different. Um, but that was the main issue, I think. And so it turns out that's like actually quite difficult to solve. I messed around with two like major approaches to changing this. The first was within um, the resolve collision method itself. I was because previously all we had was like that single line that just updated this hitbox's velocity so that the collision wouldn't happen. And so I added on some more logic into this method that would also update the velocity of whichever element we're colliding with. So info.element, I would update both this one and the object we're colliding with. And that I couldn't quite get to work. I'm not entirely sure why I couldn't get it to work. Um, but it was kind of messy anyways. Because in order to attempt to even resolve the other object's collision correctly, you have to check intersection between that object against this object. And that requires all this other data that you have to pass into the resolve collision method. So I don't know, that one I wasn't such a big fan of. The other way I tried was in our quad tree element here in the update function. Whenever like I check for intersection between two objects, I do it both ways. So I check this object against cur, and then I would also check cur against this object. And that required some minor modifications to how like the collision info worked. I had to store like two elements instead of just the one. But that one I couldn't quite get to work either. I'm not. I can't remember why that one wasn't working. But yeah, ultimately I just couldn't solve the problem of one hitbox having its velocity resolved, and then another hitbox not being able to account for that. It's hard to explain. I definitely do not understand the problem fully, and more than anything, it was very difficult to test. like to set up an environment where I could test this behavior repeatedly, and also figure out what was actually happening. Because on the screen, all that happens is they pass through each other, right? But this is a very complex system, and it was difficult to figure out exactly where the problem was. And I think I did ultimately figure out where the problem was. I just wasn't able to resolve it. But maybe not. I don't know. So either way, as I said, this is something that I will continue working at, just sort of in my own time. And I would strongly encourage you to do the same, just because it's a good exercise in, like, thinking. And certainly, if you figure out a solution, I would love to know it. But let's look at what I actually ended up doing. So what we had before, as I've said several times, was a collision prevention system, where we would detect collisions that are about to happen and update velocities so that they no longer will happen. I've gone instead with a simpler, more naive, sort of classic AABB, axis aligned bounding box approach, which is collision resolution. So this system waits for collisions to happen and then attempts to figure out the best way to resolve them. And that's tricky, and as far as I know, like, impossible to do correctly 100% of the time. But let's look at what it does. So intersects, it no longer does any sort of ray casting or anything. It's purely a rectangle intersection. So it checks if these two rectangles are already intersecting. It'll return true, just like our contained by method. And then the resolve collision method now has to be a bit more involved, because it has to determine which direction the collision is happening from, which is the impossible part, and then also resolve it. So what we have here is an array of distances, and these are the distances between opposite sides of these two objects. So this is between, it'll help if I draw this actually. So let's say we have a red box, which is like the current element, and then a black box, which is the one that it's colliding with. Okay. So as I said, we need to figure out the distance between opposite sides of these two boxes. So like the right of this and the left of other. So I'll try and draw these in different colors here. So that would be like this distance, and in the code, I have this listed as just commented as left. So we take the position of this plus the dimension of this on the x-axis and subtract it from the position of other. Remember that these happen at, or these coordinates are the bottom left. So here we have position.x plus dimension.x gets us to this right side, and then this one is just position.x, and then we subtract those, takes the absolute value, and that gives us this distance. And then we do the same for all other sides. So we get like this distance and the distance between the top of this and the bottom of that, and then the other side here, the difference between the left of that and the right of this. Okay, so we just compute all the absolute value of all the distances between opposite pairs of sides, and then we just have a loop to determine which side is, or like which direction is the minimum distance. That's what this does. We don't care about like the actual value of the difference, we just care about which index it is, because that way we know which direction a collision is most likely to happen from. So that's what this loop does, just gets the index of the minimum value in this list. And then we have this ugly like if chain here. So this just says if this element overlaps the other element on the x-axis, then we can check for collisions on if this overlaps other on the x-axis, we check for collisions on the y-axis. So in the diagram here, like we can see that this red object here does overlap on the x-axis with the black object. If it were out here, it wouldn't. Anywhere in this range, it does, and then as soon as it passes that edge, it doesn't. So only within this area is what we're checking. If the red box is within this area, and the minimum index is 0, which is a collision between the bottom of this and the top of other. So the bottom of this and the top of other. So if the minimum distance is that little gap right there, and the bottom of this object is beneath or below, less than the top of the other object. So here it's not, but here the bottom of the red is less than the top of the black, remembering that negative y is down, positive y is up. So if the minimum distance is this direction and our red is like beneath the top of black, then there's an intersection and we can fix it. And the way we fix that is just setting the position of the bottom of the red rectangle equal to the top of the black rectangle. So just like bump it out so that it's just resting on the top of the black rectangle. And then we also set the velocity of this object, the y-axis velocity, to 0, which is correct. But then this behavior is kind of weird and something that you'll probably want to mess with. I just threw it in there just, I don't know, because it like completely solves this problem. But this also, it does the same thing as this to the other object. So if the black object, so if the red object is moving down in here, it bumps back out here and it stops moving. But if the black object is also moving, its y-axis velocity will stop as well. It'll become 0. And this works perfectly if the if these are moving towards each other. So if this one is moving up and the red one is moving down, then they'll both stop. But if this one is moving down and the red one is moving down just faster, then the red one will catch up with this one, bump into it, and the red one will stop, which is correct, ignoring momentum. But the black one will also stop. And so that's a bit weird. And you might want to do some basic checks there just to like see which direction info.element is going, and if it's going the direction opposite of the current element, then you stop its velocity. Otherwise, you just let it be. But I don't know. Again, this like solves it completely, so I just left it there. So that's between the top of this and the bottom, or no, the bottom of this and the top of other. And then this one here, as I'm sure you can guess, is just the opposite. It's the top of red and the bottom of black. And then on the other chain here is if there's y-axis overlap, so anywhere in this region, like on either side, then we check for x-axis collisions. So if the minimum index is 1, which is between the right of this and the left of other, then we do the same thing. So if I keep minimizing that, I shouldn't. So if the right of this and the left of other, so these two faces right here, if the right of this is greater than, because positive x is to the right, if the right of this is greater than the left of other, then we bump it out here, set velocities to 0, same as before. And then, of course, the same happens here, where if the left is less than the right, then we bump it out here. So the result of this, let's see, is obviously this works just as it did before, but now I have correct resolution like that, where when I'm going opposite direction of this object, they both stop. The collision resolves normal. But here you can see if I catch up to it, that also stops. So that's what I was talking about, that weirdness of like, that should probably be fixed, which I think it can. I think that's just like a simple check on the direction of info.element's velocity, and then only set that to 0 if the direction is towards the current object. So I guess I should also show you like the error that I was getting before. So this is like an older build. I have this, I can catch up to it just fine. I can hit it from all these different sides, but if I get in front of it and head that way, I just pass right on through it. Super weird. So yeah, clearly that error is fixed, although a bit weird and definitely not as clean, but it works. So let's look at there were some small like infrastructure changes I had to make just to get this to work. Because now that we're doing collision resolution instead of collision prevention, the order that we do certain operations in must change. So before, we were running scripts to update velocity and position and all that. Then we were moving hitboxes to reflect that. Then resolving any collisions, so making sure that no collisions would happen. And then once we had the correct values for that, then we would perform movement. But here you can see we just sort of do it in the opposite order. So we still run scripts first, just get all the velocity and everything settled from input. Then we perform movement first, so actually move stuff, regardless of whether or not they're collisions. Once stuff has moved, then we check for and resolve collisions. So just reordering that there. And then I had to change like a little bit what these methods do. So previously we had the update method would perform movement and then update vertices, which is correct because that was being called last. Update is part of this move in drawGroup.move. Yeah. So drawGroup.move was being called last, and drawGroup.move calls dynamic.update. So this was being called last, and so the final values of position for that frame were being used, which is correct. But now resolve collisions is being called last. You can see there, and so whatever values are set here are the final values for this frame, and so those need to be what are used to draw. And you can see it doesn't like break anything by any means. The whole system still works just fine. I guess I'll sort of undo the changes I made here just to show you what that looks like. Okay, so I've got this. I can't pass through those just like normal, and if I shoot something, same thing, all that still works. But what you can see is there's visual jitter because the position values that are drawn are calculated before collisions are resolved. So what's happening here is this box is moving into the other box and then being drawn. So it's like being drawn somewhat inside of the other one, then being pushed back out and being drawn. So it's in the correct place, but then moving back down into it again. So that's what the jitter is there. It's just caused by not updating things in the correct order. But yeah, so other than like what's happening in the Hitbox class, that is obviously a total rework, but everything else was just some minor changes here and there. So I think that's it. I did make one last change in here, which is, yeah. So I updated, I'll just delete these for now. I updated our player script to just be better. Because before it was like spawning a projectile inside of the player. You can see here it's just setting the position of the projectile equal to the position of the player. And that worked fine in our previous system. I mean, it wasn't like an intended feature, but it still worked somewhat in our previous system where once a collision was happening, it was just allowed to happen because you can't prevent something that's already happened. But now that we're resolving them, whenever I, spawn something inside of myself, it just gets pushed out in some way and its velocity stops. So clearly that's not much of a projectile. So I just made some changes here. It is like kind of a lot of code just because it's like assembly language, but it's pretty simple. So all this is doing is getting the direction of velocity like as a unit vector, so 1, 0, or -1. Then I get half the player's dimensions. then I get half the projectile's dimensions, I add those, and I multiply the result by the direction of velocity, so the direction that this thing is going to be moving in. And then I just take that and add it to the position, and then finally set the position of the projectile. So all this does really is just make sure that, like, if I have projectile that would be spawning inside of myself, all it does is it takes my position, then adds half my dimension. So say I'm moving, this way. I'm moving to the right, so my projectile is going to be shot to the right. So it adds half my dimensions, and then it takes half the dimensions of the projectile and adds those, and just multiplies by that movement direction vector. So in this case, to the right, obviously I've drawn these arrows pointing to the right, and then my thing will spawn like just touching, the projectile will spawn just touching the player and then continue moving that way. And this works for every direction because like the magnitude of this is computed, it's just a number. It's not really, I mean, it is a vector because dimensions have x and y components, but that's just a convenience thing. The actual direction that this resulting arrow faces is determined entirely by the direction of velocity, which is this statement here. Multiply the direction of velocity by my dimension vector. And obviously that if I'm moving just to the left or just to the right, then the y-axis position isn't affected, so it'll spawn just to the left of me or just to the right of me. But if I'm moving sort of at two directions, it'll sort of spawn. Oh, that is weird. I think all the math there checks out, but this is like more weird collision stuff because, yeah. So what's happening here is if I'm moving in two directions, then it's still spawning within me because. Let me do this a bit differently. So I have, I think I'll draw this arrow like down here. So I have half of my dimensions and then half of the projectile's dimensions. But now I need to spawn the projectile up here because I'm moving at an angle. And so if I just take this guy, move it here. Oh, I don't think I can rotate. So I'll try and draw an equivalently sized line. It'll try and put it there, which is going to be like the center of the projectile. And obviously that's a collision, so that's why it's just stopping there. Let's see if we can fix that, actually. That's probably not too hard to fix. I mean, all we have to do to fix it, like, really hackily is just multiply multiply the resulting vector by 2. I mean, really, like, bare minimum, it should be square root of 2. Oh, didn't like that. You can see that now spawns like quite far away from me, but also I can spawn them going in 2 directions now, where if I'm moving diagonally, it does like that. And all you'd have to do here to make this correct is just check whether or not you're moving in both axes, so whether this vector v3 has x and y axis components, and then if so, divide it by square root of 2. Like, exact same thing that we were having to do for movement early on in our game loop here, where we were computing the difference between A and D and W and S, and if both of those differences were non-zero, then we would divide by 2. But yeah, I won't do that here. I think I've explained well enough how to do it, and also this is just like a stupid example that you would never use. Okay, So thanks for watching this. Sorry, like it's pretty unfortunate that that bug came about. Like I noticed it like as soon as I stopped making the videos. I wish I'd noticed it earlier so that I could have fixed it properly. But whatever, the solution does work. So I'll see you later.